This is the first of two videos going over the Unit 2 exam. I'll do the problems on this video that do not involve word problems, and on the next video I'll do all the word problems. The first group of problems is about simplifying expressions, and our steps to that are to first distribute through any parentheses that we see, secondly to eliminate the parentheses correctly, and then lastly is to collect like terms. So in the first problem, there are no parentheses, so we're only collecting like terms. So I see the 4y and the 2y. Those are both positive and added together, so that is 6y. And I see the -7 and +9. So I have to do that correctly. Those have different signs, and so I'm really just looking at the difference between 7 and 9, which is 2. The positive number there is bigger, so that's +2. In the second problem, there's no constants to distribute through. There's only the elimination of parentheses. And so the rule is if we have a plus, so nothing at the beginning means it's a plus. If we have a plus in front of our parentheses, we can just drop them. And if we have a minus in front of our parentheses, then we can drop them. But when we drop them, the signs become reversed. So this was a +7, and this is a +4. And so those become negatives down here. And then again, we're collecting like terms. We have 9x minus 7x, it's +2x, and +2 minus 4 is -2. In the third problem, we have to use a distributive property to move the numbers multiplied outside the parentheses through the parentheses. And there's more than one way to think about this. It might be easiest to just remember that subtraction is just adding the negative, and that might make it seem like you're only having to do one thing. So let me just rewrite this. So this is one, oops, I didn't mean to write an X there. This is one way to think about it. If you're happy with how you think about it and it's working for you, don't pay any attention. But if you're having trouble with this is another way to think about it. So instead of thinking about subtraction, don't think about subtraction with these numbers outside. Just think of them as adding a negative. If you do that, then when I distribute, this -4 is going to get multiplied inside each of these terms. So -4 times +5 is -20, or -4 times +4 is -16. And I would leave parentheses on here. I'm never quite sure about doing more than one step at a time. When I multiply, notice that I'm leaving this plus alone. One of the reasons for changing it to a plus is so that I don't have to think about different rules for plus and minus. Now when I'm multiplying this -3 through, I've got to multiply it there and there. And so -3 times 7r is -21r. -3 times +1 is -3. And now I still have the parentheses there, but it's because everything is plus, right? That's positive at the beginning, there's a plus in the middle. I can just drop the parentheses entirely. So I've just copied everything down exactly as I had it before, but I guess I didn't put the plus back in there, but adding -21r is just subtracting 21r. So this will get me back to where I want to be, -20. I have -20r, -21r. Those have the same sign. They're both negative. So I've got -20 and then another -21. So altogether that's -41r. And I have -16, -3. Again, both are negative. So I'll have -19 between the two of them. The only thing I'd say about these evaluation problems, this went fine. I mean, again, you have a calculator in front of you, is that if you're going to put this in your calculator, then err on the side of adding parentheses and then put it into your calculator exactly that same way. So for example, and this is especially true when you have negative numbers that you're plugging in. When I change the x to 7, the top becomes 4 times 7. I put the 7 in parentheses. And then plus y, y is negative 1, so I put that in parentheses. And then the denominator, I do negative 1 minus 2. For the ones that are a fraction, the easiest thing to do is, rather than try to hold all that in your calculator, because it can get quite long, is just do each part separately. So do this in your calculator, and you'll get 27. Do this in your calculator, just type it in exactly as it's written, and you'll get negative 3. And now you can do this part as a separate step in your calculator, and you'll get negative 9. So the main thing is, don't try to put the entire thing in your calculator at once, and also bring parentheses with numbers when you're substituting into an algebra equation. So in the second one here, I'll have the x becomes 2, the y becomes negative 5, and the z is 6. So that's even got more parentheses than it really needs, but that's following my suggestion of every time you change a letter into a number, just put it in parentheses. If you do it exactly that way and put it in your calculator exactly as it's written, you'll get negative 32. Okay, solving equations. This went pretty well for the most part. There's one step that seems to throw people, and that's when we end up with negative numbers in front of our variable. And so one thing we can do is we can try to avoid that as much as possible. So for example, in this problem, our steps are simplify the two sides and then move all of the variable stuff on one side and all the non-variable stuff on the other, and then we can do a division on both sides or multiplication on both sides to finish. So we have kind of a three-step process for this, but the first step is simplify. So 14y plus 13y is 27y. 14 plus 4 is 18. So with the left-hand side, if I simplify the left-hand side, it's just 27y plus 18 equals 6y minus 7. So now I would like to get my variables on one side and my non-variables on the other. Notice that it doesn't make any difference which side is which. So in this problem, for example, I could either subtract 6y from both sides, and that'll make it go away on the right, or I could subtract 27y from both sides and it would go away on the left. One of those two things results in having a positive number in front of the y. Subtracting 6 from 27 leaves me with a positive number. Subtracting 27 from 6 leaves me with a negative number. It's completely up to me which one I do. And so one strategy that might help for the error some of you are making is always subtract the variable expression in a way that does not end up with a negative number. So in this case, I'm going to subtract 6y from both sides. And that will give me 21y plus 18 on the left. And the 6y minus 6y will cancel. I'll have just negative 7 on the right. Now, I want to subtract 18 from both sides because I don't want this to be here. I want to have nothing over here except for the 21y. So subtracting 18 from both sides. And notice that is going to force me to have a negative number on the right, but more people were messing up when they had negative numbers in front of the variable than they were messing up when they had negative numbers on the other side. So I still think this is a good idea. So in your calculator, you can do negative 7 minus 18, and you'll get negative 25. So this equation will become 21y on the left and negative 25 on the right. So our first goal is to separate the stuff that has the variable in it, the y in this case, from the stuff that doesn't, and we've done that. And now we can just divide both sides by 21. And there's no common factors between those. 25 is 5 times 5, and 21 is 7 times 3. There's not going to be any common factors that allows us to reduce that. So negative 25 over 21 is the answer. In problem 7, we have to be careful that we're simplifying each side correctly. So don't forget our distributive property. Multiply the 7 times both things. Multiply the 8 times both things. Again, up to me how I subtract. So I'm going to subtract 7y from both sides because 8 minus 7 is positive and the other way around is negative. So this will help me not have negative numbers in front of my y's. 8y minus 7y is y. And on this side, I just have 56. Now I can add 16 to both sides. 56 and 16 is 72. And there's no final step. That actually, just separating the y from the other thing gives me the actual solution. So y should be 72. Number 8 is similar. I won't do that one. Let me talk about number 9. This one, oops, that's weird. It's not going to all move. Oh, well, all right. Number 9 caused some people some problems. The fraction always makes people freak out a little bit. But people were trying to do the right first step, which is good. So the correct first step is multiply both sides by 4. And the reason we want to do that, the reason we want to do that is that this part, 4 times n over 4, simplifies. And I think that's where people are messing up a little bit. Remember, this is just multiplying fractions. So this is really like 4 over 1 times n over 4. And that's 4 times n over 1 times 4. And because we have 4 times in both, they cancel out. So this is the left-hand side. When we multiply n over 4 times 4, we just end up with n. And on the right-hand side, we have 24. So the answer here should be 24. This does raise one thing. This was such a common mistake that it was a little frustrating because this is a really nice whole number answer. Don't forget that you can check answers, and especially if they're nice whole number answers, you should check them. So taking this 24, I can take my 24 and I can go all the way back over here to this equation, and I can just ask myself, is this true? Is 24 divided by 4 equal to 6? That's a really, really easy thing to check in a calculator. So if you had a number here that was wrong, you should know immediately that it's wrong because it's very easy to put back into the formula. Similarly, this would be a very easy number to check. If you put that into here, these numbers are kind of big once you plug it in, but with a calculator, it's not hard to put 72 into this side and see what number that is. Put 72 into this side, see what big that number is, and if they're the same thing, then you know that you're correct. So please, please, please check answers on these because it's easy to do so. I don't know why this isn't moving. Oh, well. Got something crazy going on. There, that'll show it. Ah, damn it. There, okay. Let me move down to number 11 because it has a problem that it has the negative numbers that are sort of stuck in front of the x's. And so my goal of having a positive number in front of the x is kind of thwarted by this example. Negative 13x and minus 15x, minus 13 and minus 15 together. If I do minus 13 minus 15 on my calculator, I'll get minus 28x minus 21. And of course, the right-hand side, 17 minus 1 is just 16. So that's what I get by simplifying the expression on the left. Now I can add 21 to both sides. And I'll have minus 28x equals 16 plus 21 is 37. So now I want to divide both sides by negative 28. And that will be my correct answer. So there's nothing really weird that happens when you have a negative number in front of the x that you have to divide by, but you have to remember to do it. One of the common mistakes that I saw was when people got to this stage, they just dropped this minus sign when they went on that last step. So don't forget that it is there. So 37 over minus 28, or the same thing as minus 37 over 28. It's the same thing. Finally, let me do one more that has, whatever I did with it, oh, there it is, that has a fraction in it. This came from the other page, so I just dropped it down here. Because this has a fraction in it, it seems like it's a little bit harder. But again, the people were doing the right step, but then they were kind of freaking out at how to simplify things. So in this case, the only denominator I see is a 2. So multiplying both sides by 2 seems like an obvious first step, but we need to make sure we're doing it correctly. So this is what I would have if I multiply both sides by 2. On the right-hand side, I have to distribute this 2 through the parentheses. Sorry, on the left-hand side. So I have 2 times 5x over 2 plus 2 times 35. 2 times 35 is 70. On the right-hand side, I have 2 times 5 times x. So that's just 10 times x. The key here is that these things are going to cancel. Right? The reason for multiplying by 2 is that a 2 in the numerator, which is basically, remember, that's like 2 over 1. So that 2 is really a 2 in the numerator, will cancel with a 2 in the denominator. And so what I end up with when I say I've simplified that right-hand side is 5x plus 70 equals 10x. Now I can subtract 5x from both sides, and I'll have 70 is equal to 5x. And if I divide both sides by 5, then I find that x is 70 over 5, which is 14. Okay, so that's it for the problems to solve. I will be sending you this. This is one of the exams from Friday. I'll send you the whole kit that has all 4 different versions on it. Please try all 4 versions and pay attention to these sort of things that I've highlighted. The answers will be included in the packet that I send, so check your answers, and should be in good shape for taking this for the first time or retaking it if you need to next week.